So, homework 32 starts out and it talks about the domain of a rational function. When they're asking you about the domain of something, they're trying to find out what kind of answers or what kind of numbers you can put in for x and get a real number answer. What they want you to know on this one is that your denominator can never equal 0, right? If you have 0 on the bottom of a fraction, you get a math error. If you take your calculator and you try to do a fraction like 5 over 0, it's going to give you a math error because the bottom of your fraction can't ever be 0. And so when they ask you about the domain of a rational expression, they're talking about a fraction, and what you're going to do is you're going to look at the bottom of the fraction, which in this case is the x squared plus 5x plus 4, and you're going to say, oh, I know that on the bottom of the fraction I can't ever have a 0. We're going to solve this one by factoring since it has the squared term in it. So last week Jane worked with you on factoring. So we're going to factor that out with our 2 sets of parentheses. We know it came from FOILing. We factor the leading term. What times what gives me x squared? X and x. Since both of my signs are pluses, tells me both of my signs are going to be pluses down here. Plus and a plus. So I want the factors of the n number 4 that add up to the 5 in the middle. What pair of factors for 4 add up to 5?
4 and 1.
4 and 1, exactly. And then we're going to just break it into 2 separate problems. Either the x plus 4 can't equal 0 or the x plus 1 can't equal 0. And so when we solve each of those, we're just moving our number to the opposite side, which changes our sign. So here, x can't equal a negative 4, and over here, moving my number, x can't equal a negative 1. Since in the question it asks which ones are not in the domain, they're not going to use the not equal sign. They're just going to say, oh, what 2 numbers can't x equal? Negative 4 and negative 1. So number 2, same kind of thing. We want to find the values that are not in the domain of h. H is a fraction, and we know that with fractions, the denominator of our fraction, x squared minus 17x plus 72, can never equal 0. Again, on this one, we have one of those quadratic expressions with the squared term that we have to solve by factoring out. So we use our 2 sets of parentheses. Factors of x squared, x and x. This time on my signs, the end is positive, but the middle is negative. I know if the end is positive, both signs have to be the same, so they're the same as the middle, so I'm going to have a negative times a negative. Right? A negative times a negative is a positive, and they add up to a negative in the middle. So this time I want the factors of 72 that are going to add up to the negative 17 in the middle. 9 and 8. A negative 9 times a negative 8 is the positive 72 on the end. Negative 8x plus the negative 9x gives me the negative 17x in the middle. Again, we're going to say that the x minus 9 can't equal 0, and then the x minus 8 can't equal 0, but we got to move our numbers over so we get the opposite answers. And so the 2 values that are not going to be in my domain would be what 2 numbers?
9 and 8.
Positive 9 and positive 8. So third one, same kind of thing. I want to find the values that are not in the domain of g. We know we have a fraction. We know that in the fraction, the denominator, the x squared minus 1, can't be equal to 0. Again, this one does have the squared term, so we know that it came from factoring out using my 2 sets of parentheses. This one, maybe you recognize right away, is the difference of perfect squares. If not, you still factor it kind of the same way. Factors of x squared, x and x. If the n sign is a negative, I'm going to have a positive and a negative. And then the factors of 1 that give me 0 in the middle. Well, there's only one pair of factors for 1. 1 and 1. I get a negative 1x and a positive 1x, and that's why I have 0 x's in the middle when I FOIL that out. So again, we're going to set each of those and say they can't be equal to 0. Otherwise, I'd have 0 in the bottom of my fraction. I solve them by moving the numbers over to the other side. Put my 0 on that one. And so I'm going to minus my 1 here and plus my 1 here. So the two numbers that are not in the domain here, negative 1 and positive 1. Sometimes you will have ones where you don't have the square term and you just move the number over and it's pretty easy to solve. But most of the time they like you to practice your factoring, which we're going to do on the next ones.